Okay, let's do some examples of computing definite value of the definite integral using limit of right end point approximation. Here we have, so we are trying to form Rn, which is delta x f of xi, I going from 1 to n. Here, delta x is the length of subintervals, so we divided them into n equal subintervals. So this is 2 to the power n. And xi is going to be a plus I delta x, which is going to be 0 plus I times 2 over n. And this is 2I over n. Then, while we can form a sum, the sum is going to be 2n e to the power 2I over n, I going from 1 to n. This is Rn. But there is no I here. I can put it outside. That's a constant in the summing variable. And I can write this thing as 2 to the e to the power 2 over n to the power I going from 1 to n. Remember, when we have r to the power I going from 1 to n, this is going to be r minus r to the power n plus 1 over 1 minus r. Here r is e to the power 2 over n, so we have 2 over n times e to the power 2 over n minus e to the power 2 over n to the power n plus 1 over 1 minus e to the power 2 over n. Okay, well, let me just write it a little bit better here. What we have is to the power n, well, 2 over n is here. This is e to the power 2 over n minus e to the power 2n plus 2 over n, and this is 1 minus e to the power 2 over n. Very nice. Now we have to find the limit of Rn as n goes to infinity. See, the limit of the numerator, which is 2 times 2 over n minus e to the power 2n plus 2 over n. The limit of the numerator is, well, the first one, e to the power, e to the power 2 over infinity is 0. So e to the power 0 minus, there's a 2 multiplied. As n goes to infinity, this will be e2. So this is going to be the numerator. The limit of the numerator is 2 minus 2e2. Limit of the denominator is what we have to be a little bit careful about. And why is that so? Because when you, let me just open a little bit more space here. When you try to find the limit of n, 1 minus e to the power 2 over n, as n goes to infinity, this is going to give us infinity times 0. The trick here is that use 1 over 1 over one of these functions. And well, this is the same thing as we have this guy, x instead of n there. Then we have 0 over 0. We can use Labtube's rule, and this will give us limit negative 1 over x squared. This will be plus 2 over x squared e to the power 2 over x. This cancels with that, and n goes to infinity, x goes to infinity. This gives us, well, this is 1, 2, negative 2. So the denominator has limit negative 2, hence the limit of that guy is going to be equal to 2, 1 minus e squared over negative 2. Which these two cancel and you get e squared minus 1. And we know that this guy is 0 to 2 e to the power x dx. Yes. So we found the value e squared minus 1. How about this other one? Well, again, we compute Rn, the delta x. Delta x here is 1 minus 0 over n, 1 over n. Xi is going to be a plus I delta x, which is 0 plus I times 1 over n. So this is going to be negative I over n. And then Rn is going to be I going from 1 to n, delta x. F of x is this guy. So we have I over n cube minus 3. And 1 over n goes out. We have I equals to 1 to n. This is I cube n cube minus sum 1 over n. 3I goes from 1 to n. This guy now, you see there's n cubed down there. I can take it out. This will be n4, and I have sum of cube integers minus, well, this is 3 over n sum of 1. I goes from 1 to n. Well, we know the formulas for these guys. The formula for the sums of cube integers is that we have n squared, n plus 1 squared over 4. And for this part, sum of 1s is n. So what we get here is that n squared, n plus 1 squared over 4, n to the power 4 minus, well, this cancels with that, minus 3. And, well, the limit of Rn now, n goes to infinity, is limit of this piece here. I can expand that, actually. I can write n4 plus 2n cubed plus n squared over 4n to the power 4. As n goes to infinity, there's a minus 3 also there. Well, this limit is easy to compute. The highest powers, it will give us 1 over 4 minus 3, which is 1 minus 12 for negative 11 over 4. Since the function is continuous, knowing the theorems and facts, this is equal to the value of the integral, definite integral, x cubed minus 3 dx. And, well, other polynomials you can do compute, and for some other exponential function you can also do compute, but this is basically the stretch of this method we can get. Again, we will need more tools, more theories, more facts to be able to do compute more definite integrals.